All right, everyone, welcome to lesson 4, our third last lesson for this unit. The topic is volume, so we are going to learn how to calculate volume of 3D shapes. So in the first 3 lessons, we started to learn about perimeter and area. And so perimeter and area are exclusively only for 2D shapes, flat surface shapes. All right, so imagine just drawing a rectangle on a piece of paper. For something of that nature, you would find the perimeter or area of that shape. But when you're talking about 3D shapes, you're talking about shapes that are kind of popping out at you, right? These are the shapes that we see all around us in real life. We see 3D shapes. And we're going to learn what the term volume means, how it can apply to our real lives, and different examples in our real lives that include volume. There are many of them. And then we'll learn how to obviously solve some volume type questions where we're going to use formulas. All right, now the tricky part to this lesson is going to be choosing the right formula, knowing how to substitute all your values into the formula correctly, and then just following BEDMAS to solve the formula. So that's going to be the challenge here. And before we begin, I do want to just go into our formula sheet from lesson 1. So I'm just going to open that up. And I want us to take a look at the formula sheet. Remember that the first page only has 2D shapes. All right, so this first page is all just 2D shapes. And as we get down to the second page, you see 3D shapes, and you see a whole bunch of formulas for volume. Okay, and you can see that it looks somewhat complicated. We see kind of 2 formulas or sometimes 3 formulas in each box. Okay, and as we go, I'm going to explain what's going on there and why you see V equals area of base times height, for example, and then below that you see V equals pi r squared times h. So I'll explain all of that just so that you know how to use your formula sheet, because that's extremely important. Okay, so let's go back and let's begin by defining the term volume. Okay, so how would we define the term volume? Well, I would say that it is the empty, in its most simplest terms, it's the empty space occupied within a 3D shape or a 3D figure. All right, so what do I mean by that? I mean that if you have let's say a cylinder glass, and you were to fill that up with water, then you're dealing, the amount of water that's in that glass, you're now dealing with a volume situation. All right, and that's different than area. If you can think of the example that I used in the last lesson with respect to area, one of the examples I used was covering, let's say, your backyard with grass. All right, so imagine you have a flat surface. Imagine your backyard is just a rectangular shape, a rectangular flat surface, and you were going to cover that surface with grass. Right, that would be an area situation. But in this case, we have a 3D shape. We have a glass of, let's say, a glass that you would fill up with water. That's popping out, that's sticking out. It's not just a flat shape. And filling that up with water would be a volume situation. Okay. Here we have a list of different 3D shapes, pretty much all of the ones that we're going to be dealing with in the next few lessons. All right, so the first one being a cylinder, the second one being a cone. All right, now just a quick question before we move on, because there's a similarity here between this cylinder and the cone. My question to you is, if our diameter of these circles were the same. Okay, so let's say that this was a diameter of 5, and this cylinder had a diameter of 5. And let's say that the height of this cone was, let's say, 8, and the height of this cylinder was also 8. So they have the same diameter and heights. What would you say if I had to ask, how much larger do you believe, or how much more water do you believe the cylinder can hold than the cone? If they have the same diameter and the same height, how much more water do you believe the cylinder can hold than the cone? I want you to keep that in mind, and we're going to answer that a little bit later. Okay. Next we have a prism. Okay, prism and period, and often students will get confused with those terms. So let's try to remember the difference between a prism and a pyramid. The easiest thing to do is a pyramid always comes to a point on one side only. All right, so, and you can have different types of pyramids. You can have a rectangular based pyramid, which is what we have here. That's a rectangular based pyramid. In this case, we have a 5-sided base, right? We have 1, 2, 3, 4, 5. So that's what's called a pentagon. So this would be a pentagonal based pyramid. Okay, so maybe we'll write that out. So something like this would be a pentagonal based pyramid, whereas this one over here is known as a rectangular based pyramid. Now, both are pyramids, right? So they're both pyramids, but there's obviously many different types of pyramids. You could have a square based pyramid. You could have a hexagonal based pyramid, which has 6 sides. Okay, and the list goes on and on. So remember that a pyramid comes to a point on one side of the figure, whereas a prism doesn't do that. So a prism, when we're talking about prisms, I'm talking about a cube would be a prism, all right? A rectangular prism, a triangular prism, all right? Those are all different types of prisms, and you have to know the difference between your prism and your pyramid. Okay, so here's a cube, but a cube is really just a special type of prism. Okay, so remember that. It's just a special type of prism. It would fall under the prism category. And then lastly, we have a sphere, which is basically like a ball. All right, so I think we all already know that. And that's it. I mean, the sphere is just basically a ball. Let's move on. Now let's remember that question that I asked you above. How much more water do you think the cylinder can hold than the pyramid, right? Keep that in mind again. Okay. The next questions here, the next 2 questions, just kind of take us through what we just discussed. So circle the shapes that are prisms or cylinders. All right, so I'll circle a cylinder. This looks like either a cube or a rectangular prism. This is a prism. Okay. This is a pyramid, so I'm not going to circle this one. What about this one here? That is in fact a prism. Okay, so this is what's called a triangular prism. Look at how it's different than a pyramid. Do you see how it's different than a pyramid? So a prism does not come to a point like a pyramid does. Okay, and you can also have a triangular prism, right? It does not come to a singular or a single point like the pyramid does. All right, so that falls under a prism, that shape right there. And then a sphere and a cone obviously are not types of prisms or cylinders. Next, circle the shapes that are pyramids or cones. Well, here's a pyramid. There's your cone. Okay, so let's get back to that first question that I wanted you to think about. So let me scroll up. how much more water do you think this cylinder will hold over this cone if you have the same diameter and the same height? If you guess the number 3, you guessed correctly. So a cylinder would hold 3 times more water than a cone if the diameter and the heights were the same. Okay, so the magic number there is 3. So I'm just going to fill in this question here where it says, okay, my volume of a cone times 3 would be the volume of a cylinder. And this is important to remember. So a cone, it's 3 times smaller. It holds 3 times less liquid than a cylinder. Okay. What about the volume of a square pyramid? All right, so let's say, for argument's sake, that this was a square-based pyramid, this right here. Okay, so let's assume that that is a square-based pyramid. Now, let's assume that this is a square prism or a cube. Right? How much more water do you think that square prism would hold over that square-based pyramid? Once again, if you guess the number 3, you're correct. So a square-based pyramid is 3 times smaller than a square prism or a cube. Okay. Now, there isn't any situations where we're going to be dealing with this, so I'm not going to be too concerned about that and try to add that to what you already need to know. All right, so none of the questions are going to deal with that. So let's move on and let's come up with our conclusion. Okay, so the volume of a prism is 3 times the volume of a pyramid, okay, with sides that are equal. Meaning, for the cylinder and the cone, that the diameter and the heights are equal to each other. All right? So, let's now come up with a formula for the volume of a prism. Now, I know we can use the formula sheet here, but let's try to think of what our formula would be for the volume of a prism. So if I were to draw right now, let's say I'll do my best to draw a rectangular prism. Okay, it's not the best, okay, but hopefully you kind of get the idea. My rectangular prism, not very good. Okay, a little bit difficult drawing with this pen. So, the volume of a prism, right, and in this case it's a rectangular prism. I can tell you that for all of these volume questions, you're going to make life a lot easier on yourself if you remember this one thing. That for the volume of any of the shapes we're going to deal with, the formula is always the area of the base, that's a subscript base there, so capital A subscript base, times the height of your prism. So essentially, we're going to take the area of the base, so this side that I'm coloring in, if I could find that area, okay, then multiply it by the height. Okay, so if I can find this area here, and then multiply it by my height, I will get my volume. Okay, I'll be able to figure out how much water it takes to fill that shape up if I could find the area of the base and then multiply it by the height. This is key. Instead of remembering or trying to, get confused with complicated formulas, if you just remember that it's area of the base times height. And then I can interchange the base shape, right? Your base could be a square, right? It could be a rectangle. It could be a triangle. It doesn't matter what the shape is. You'll be able to remember it easily if you know that it's area of the base times height, okay? And know that the base can change shapes. All right, so you can have all different shapes. Same thing with the cylinder. Okay, so, and actually I should probably write volume of a cylinder here because it's not included. So the volume of a cylinder, also area of the base times height. Now it just so happens that the base of a cylinder is a circle, so the area formula for a circle would be different than the area formula for this rectangle here, right? So that's interchangeable. The area of the base is always interchangeable, but the overall idea to find volume is that you always do the area of the base times your height. Okay? Now, for a pyramid, it's going to be the same thing as a prism. All right? So it's still going to be area of the base times height, but the difference is going to be what? Well, the pyramid is 3 times smaller than the prism that has the same dimensions. So you're going to take that and divide by 3. So for any pyramid, you take the area of the base, multiply it by the height, and then divide it by 3. Okay? So if we can remember these two and this formula here, this general formula, then that's going to be a big help. Now, I should also add on to here your volume of a cone. Guess what the general formula is for the volume of a cone? It's still going to be area of the base times your height. But remember, a cone is 3 times smaller than the cylinder. So you take your area of the base times height and divide by 3. Okay? So for pyramids and cones, you always divide by 3. And for cylinders and prisms, you just keep it as area of the base times height. Okay? And if I go back to our formula sheet, you will see that same idea occurring. Okay, so I want us to understand our formula sheet. Okay, so here it is. Take a look. What do you see for the cylinder? Area of the base times height. What do you see for the cone? Area of the base times height divided by 3. Now you see these other formulas here. You see V equals pi r squared h divided by 3. Why do you see pi r squared h divided by 3? Well, h represents the height, and pi r squared represents the area of the base. The area of the base in a cone, it's a circle, and the area formula for a circle is pi r squared. So what you're seeing there, when you see V equals pi r squared h divided by 3, you're really just seeing area of the base times height divided by 3. Pi r squared is the area of the base, h is your height, and then divide it by 3. Okay? So that's why you see all these different formulas, or 2, sometimes 3 formulas inside of these boxes here. All right, so let's go back, and now let's just start answering questions. Okay, I'm just going to do 4 quick examples with you, okay, and then let you go off and start your work. Okay. So let's start by finding the volume of this. This is clearly a prism. Now, what kind of prism is this? Look at your dimensions. 3, 3, and 3. What kind of shape do you believe this is? It is a prism, but specifically, It's a cube. So let's find the volume. Area of the base times height is, well, what's my area of the base? Well, here's my base here. How do I find the area of that square that's 3 by 3 there? How do I find that area? Well, you do 3 times 3, right? Like length times width. But because it's a square, length and width are the same. So all you really have to say is that it's really just, let's call it, let's give this a letter. Okay, so we can either do 3 times 3 here, length times width. Okay, or a different way of showing 3 times 3, is 3 squared. That's the same thing as 3 times 3. It's just specific to a square. Because they're the same thing, we can just say 3 squared. You don't have to necessarily say 3 times 3. Okay, times the height, which is also 3. Follow BEDMAS, do your exponents first. 3 squared is 9. So what you're left with is 9 times 3. Final answer, 27. Don't forget your units. Centimeters. Now, is it centimeters squared? Should it just be centimeters, or maybe it's something else? When you're dealing with 3D, makes sense that your exponent here would be cubed. So 27 centimeters cubed. When you're dealing with volume, you're always dealing with a cubed situation. You might ask me, how many decimal places do we use? Well, look at the numbers that were given in the question. Do they have any decimal places? No. So just keep it as 27. Okay? That's kind of the rule of thumb. If it doesn't say in the instructions to round to a certain amount of decimal places, just look at the values given in the question and follow that. All right, so again, like here we have 10 and a 5, so we're going to have no decimal places again. Okay, so here we have a cylinder. So let's do V equals, again, it's still area of the base times your height. Except now, for a circle, what's your area of the base? Well, it's a circle, right? So if you can't remember the area of your base, go back to your formula sheet from lesson 1. So the area of a circle. Here it is. Area of a circle, A equals pi r squared. Okay, so my formula there is going to be pi r squared. Oops. Okay, so my area of the base is pi r squared. Okay, so pi times radius squared times my height. All right, and I'm just going to use the letter h, lowercase h, for height instead of writing out height every time. So I just now need to plug in my h. Well, what does h equal from my diagram? The height of the cylinder is 10. And I also need to plug in r. What is my r value? My radius of the circle is 5. So let's plug in all our numbers, okay? So I've got pi times 5 squared times 10. Remember, pi is 3.14, but let's do my exponent first, follow BEDMAS before I multiply. So I have to do 5 squared first. That equals 25. Now you can pull out your calculator and just multiply the three numbers together. 3.14 times 25 times 10 No decimal places. Your final answer should round to 785. And this time we're dealing with meters cubed. Okay, no decimal places. All right, so let's recap what I did there, right? My area of the base was a circle, so I looked up the formula for the area of a circle, and it's pi r squared. And then I multiplied it by the height of the cylinder. Okay, let's do the cone now. So the cone is a little bit different in that my volume formula is still area of the base times height, except now, right, it's 3 times smaller than the cylinder, so it's divided by 3. Well, my area of the base is still, so this is my base here, it's still a circle. What's the area of a circle? Pi r squared from the last question, right? We don't have to check the formula sheet again. We know that it's pi r squared. So let's replace area of the base. Let's replace it with pi times r squared. And instead of the word height, I'm just going to use the letter h and then divide it by 3. Okay, what is my radius? Well, my radius is 2. I'm going to plug that number in for r. And my height is 10. I'm going to plug that number in for h. Okay, and that's just the numbers that were shown here in my diagram. So pi r is 2, so 2 squared times h is 10. And don't forget to divide by 3. Okay, now let's follow BEDMAS. Let's do exponents first. Pi times 2 squared. 2 times 2 is 4. Okay. Now we can just pull out the calculator and do 3.14 times 4 times 10. Then press the equal button. Okay, so you should get in the numerator something like 125.6. You might be saying, but sir, why are we rounding to 1 decimal place? I'm not rounding my final answer. I'm just keeping decimal places within the question to make my final answer more accurate. All right, my final answer, I'll have no decimal places. So this is, don't forget, divided by 3. 125.6 divided by 3. Round it to no decimal places is 42 centimeters cubed because we're dealing with volume. All right, 42 centimeters cubed approximately because we rounded. Okay, let's do this pyramid. Last question. Okay, so my square base pyramid. Okay, so it's still going to be the volume is area of the base times height, except now my area of the base, it's for a square. My area for a square is what? Side squared, s times s. I mean, they're both the same thing. You could just say that it's length times width. But because they're the same numbers, 15 and 15, you can just say s squared, so side squared. All right, so I'm going to replace area of the base with s squared. I mean, you could have just done s times s there, same thing. And instead of the word height, I'm going to use the letter h. So what is my s? My s is 15. And what is my height of the pyramid? 17. So I'm going to plug those numbers in here and do 15 squared. So I replace s with a 15. And I'm going to replace h with my 17. Okay, and you will get Oh, I forgot here. Okay, let's be careful here. Let's not make that same mistake that I just did. I forgot about the divided by 3. So remember, this is a pyramid. So this is a great learning moment. I'm not gonna erase this part of the video because it's a common thing to do, right? You start doing it, you go a little bit too quickly. You know, it's definitely a common thing that could happen. Be careful. This is a pyramid, right? The shape of this is a pyramid. So the volume is always divided by 3. Okay, so be careful there. And I'm just going to embrace that, and because that could happen to any one of us at any given time if you're working too quickly and you forget. Okay, so let this be a good learning moment for us. So now I'll replace everything that I did before. So instead of area of the base, I'll use s squared times h divided by 3. By the way, I think your formula sheet uses the letter b instead of s, so it's b squared times h. Doesn't matter what letter you use. My side length is 15, so I replace s with 15, replace my h with 17, and then don't forget again to divide by 3. All right, so let's do our multiplication. First, our exponents. So 15 squared, or 15 times 15, is 225. Keep the times 17 divided by 3. So remember, just follow BEDMAS, right? Follow BEDMAS. 225 times 17 is 3825. And divide by 3. Final answer, 1275, and we're dealing with centimeters cubed. All right, so it all starts by writing out this basic formula, area of the base times height, and if it's a pyramid or a cone, make sure you divide by 3. All right. Then go ahead and find what the area of the base is depending on the shape. So in this case, it was a square. So the area of a square is a equals s squared. So I replace area of the base with just s squared. Okay. And then I replace height with h. All right. And then plug in your numbers. So my s, or my side length, is 15. And my height is 17. Don't forget the exponent 2 there. And then don't forget to use BEDMAS. You have to do 15 squared before you can multiply. So I did 15 squared is 225. Then I can multiply it by 17, which I did below. Okay? So look at how all these questions started. Area of the base times height, area of the base times height. But then we got to a cone, so it was area of the base times height divided by 3. And then we got to a pyramid, so it was still area of the base times height divided by 3. But obviously, we have a different base than the cone, so this part of my formula is where it gets different, right? So here I have s squared as opposed to pi r squared. Those are just the different areas of the different bases. Okay? The last type of question you'll see, and there is no example here of it, but just to give you a heads up, is a triangular based prism. All right, triangular based prism. Well, the formula is still volume equals area of the base times height. Okay, because it's a prism, so it's not divided by 3. It's not a pyramid. It's just area of the base times height. The difference is that the base for a triangular based prism, you guessed it, is a triangle. So the area of the base of a triangle, right? So the area of a triangle, if you can remember from lesson 1, is base times height divided by 2. So the formula would be base times the height of the triangle divided by 2, all times the height of the prism itself. Okay, so when I talk about this height, I'm talking about the actual triangle itself. So I'll do my best to draw a triangular prism here. I don't know how well this is going to go. Not good at all. Okay, but this height here, I'm talking about the triangular base right here. It's the height of this triangle. This height here, I'm talking about the length or the height of your prism itself. So I think the best thing to do is let's go to your formula sheet and just make sure that we're comfortable looking at that. Okay, so here it is. You can see in the formula sheet it uses all kinds of different letters. Okay, and so instead of using H, which is probably a good idea, they use the letter L instead of H. Okay, so for that triangular base, instead of base times height divided by 2, they do base times L divided by 2. And then they keep the height of the prism as H. All right, just so that you're using different letters, that's probably a good idea to use L instead of having 2 H's. All right, so you just find the area of that base triangle, base times height divided by 2, or base times length divided by 2, and then multiply it by your overall height of the prism. Okay, so that concludes lesson 4. We're going to move on and do some